Hi, everyone, and welcome to Friday. Yes, it's finally Friday. Sorry, I am still not there. My wife tested positive for COVID, so we're waiting on my test results to see when exactly I'll be able to come back in. All right, so while I'm stuck here at home, we definitely want to still keep going so that we can get through chemistry and not fall behind or anything like that. So, the nice thing is with technology, that's not really a big problem right now and everything. So you should hopefully be at the question of the day in your workbooks, just like always, right? And the question of the day is right here for us. An atom that loses three electrons becomes, well, an ion with what charge? And so that's what we need to explore today. What in the world is an ion and everything like that? So let's get into the question of what an ion is, right? All that an ion is just an atom that has a different number of electrons from the number of protons it has. So remember, when we talk about the word atom, it implies you've got one, two, three, four protons here in this atom, for example. And if it's an atom, it's got to have one, two, three, four electrons, right? The word atom implies that it's got the same number of protons as it has electrons in there. Now, what the question of the day is asking is what happens if one, two, three of them just disappear? And we can get into later, why that happens. But remember the example with the Van de Graaff generator where electrons are being pulled away from different atoms, or if you shuffle your feet on carpet, it could be as simple as that. Well, what happens is now that atom becomes an ion with a positive three charge, right? Because this proton right here and this electron, well, they kind of balance out. If it was just the two of them, there'd be no charge at all. But look, here's positive, positive, and positive charges. So if you were to take your finger and touch this guy, you would become electrocuted, just like the day of the Van de Graaff generator and everything. Right. So the question for the day, or well, the answer for the question of the day is positive three. Right. That's the answer that you want to have in there. And then for a picture, maybe, I don't know, something like this, right? If you just have a circle with, it doesn't even have to be four. If you had two pluses in the center of it and one minus on the outside, or you could go the other way, you could have four pluses here and say five electrons around it. Well, that means it's an ion. So kind of like an isotope. If you remember when we did isotopes, an isotope just is an atom, but it has more or less neutrons in the center of it. If we're talking about electrons, it just means it has more or less electrons spinning around it than it normally should have, right? So that's kind of the difference of what's going on with those and everything. Right, so if you flip on over to your vocabulary words, there is but one, just one vocabulary word for today, ion, since that's what we've been talking about here. All right, all that it is for an ion, right? It's basically an atom that's electrically charged, right? It's an atom that's got more or less electrons added to it. And then for the picture, like here's my little picture for for our vocabulary word today. Look, it's got one, two, three protons. It's got one, two, three neutrons in there, so that's all nice and normal. But it had one, two, it had three electrons, but look, one of them's being pulled away, right? And so because there are more protons than electrons, that means it's positively charged. If it would gain an extra electron, let's say, well, then it just becomes negatively charged, and it's a negatively charged ion. Um, so my example is an atom losing an electron, but remember, for an example, you could just as right put in there atom gaining an electron, or maybe two or three extra electrons in there. Also, for a non-example, I put in isotope, so don't confuse those, right? Isotope, again, it just means extra neutrons or less neutrons are in there, whereas ion means extra or less electrons for it, right? So we're still always talking about atoms. We're just being more specific with exactly what's going on with them. And with ions, yes, there is electricity going on here. You would get shocked with those ions if you're touching them. Here's some other examples, right? Remember, we did the Van de Graaff generator a few days ago, right? Where you're changing ions, right? Basically, you're touching atoms that are ions because they have extra charges with them and everything, right? So here's my example of just a regular good old fashioned atom right up here, three protons, three neutrons, three electrons. But here it becomes an ion because it loses that one electron, right? Just like before. Or here's sodium, right? With 11 protons, and here it's got 11 electrons spinning around it. But now, right, the number of electrons is different, right? So once that number of electrons is different, it becomes an ion. So in this case, 11 protons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons, right? It's missing one electron. So that means it's an ion. That means you would get shocked if you touch that thing. You gotta be really careful with it. Okay, joke of the day. All right, are you ready for the joke of the day? Sorry we missed it yesterday. What did one ion say to the other one? come on. I've got my eye on you. It's bad. It's so bad. It's so bad. Sorry, everybody, but it's funny. It's so bad. Okay. Okay. Last thing for this part is we'll get into next week, right? Where we need to go next week, whether I'm there or not. We need to keep moving forward and everything. So we need to get into the three kinds of bonds that atoms have, right? So the first kind of bond is called ionic bonding. That involves piracy. Yes. If you ever liked pirate movies, there you go. That's ionic bonding. So we'll talk about that one day. The next one is going to be the opposite of it, covalent bonding. Did you ever hear about the hippies? And just share, your ice cream with each other and everything is going to be great, right? That's covalent bonding. And then the last one is called metallic bonding. And that one is like the ocean. If you like go visit the ocean like I do, then there you go. Then we'll talk about metallic bonding. So those are the three big types of bonding that we need to get into towards the end of our chapter here. All right. So that's that kind of stuff that we need to get to. There are two other things that we need to do today. All right. First is your workbook. And let me see here. Okay. In your workbook, right? There are a couple pages that are all listed in the Schoology thing that we need to get to. This page, the first one is page 27, right? So in your workbooks, page 27. Well, they're talking about ions again, right? So it describes, what is an ion? Basically an atom that's got an electric charge. It has more or less electrons than it normally should have. It does this by gaining or losing electrons, right? Polyatomic ion just means it's a group of atoms that are bonded together with either an overall positive or negative charge. So it's kind of like a whole bunch of ions put together, right? So that's what poly means. Poly just means many atoms that are ions, right? Polyatomic ion. So what they do is they have this picture at the bottom of page 27, or I guess it's really two pictures that are down here and everything. Both of them are chlorine, but one's a chlorine atom and one's a chlorine ion. And you want to answer the 6 questions that are up here. So first, how many protons are there in chlorine figure number 1? Well, there's 7 protons. And because it's saying it's chlorine and it's 17, that can't change. The number of protons doesn't ever change. It's got to be 17 all the time and everything. So what? How many protons are there? There's 17, right? How many electrons are there in the chlorine atom? Well, it's an atom, so you don't even technically have to count, right? It's saying 17 is the number of protons it has. If it's using the word atom, it means there are 17 electrons there, so you can just fill that guy in like that. Compare the number of protons and electrons. Does the atom have an electrical charge? And the answer for number 3 would be no, right? For every 1 proton in the center, 1 electron is on the outside of them, right? So they kind of balance out in that way. Hold on here. You can see me now. No, now you can't see me. And now you can see me as I fight with Microsoft and its way of doing things. There we go. Okay. Then let's see here. Okay. For question number 4, how many protons are in the chlorine ion figure number 22? You don't even have to look. It's still chlorine, so it's still going to have 17, right? You can't change that and still have chlorine. But how many electrons are there in the chlorine ion? And they kind of make it easy on you here. They're saying, look, you have the same number here, but look, you gain 1 extra electron that's here, that's not over there. So that means, right, there's going to be 18 electrons in there. And sure, for number 6, right, does the ion have an electrical charge? The answer right here is you betcha yes. You would not want to be touching this guy over here unless you were looking for a shock. Okay, so that's page number 27. For pages 28 and 29, all right, what they're doing is they give you some pictures right here, right? You've got some atomic pictures of different atoms or ions and everything. And they want 2 things, right? Make sure you get both things in there so you get all the points for these 2 pages, right? First, just find the name of the atom, right? Or the name of the atom. Find the name of the element. So for that, it's always the protons, right? How many protons it is what element it is. So to help you with that page, let me see here, page number 20. If I can scroll up here. If you look on page 20, I went too far. Here you go, page 20. Right here, they have a lovely periodic table for you, and it tells you, the name of the element. It tells you the, atomic symbol, and the atomic number is the big thing, right? That atomic number is how many protons it has, and that's how you can fairly easily tell. We go back down to the page that we're at. Here we go. That's how you can easily tell, which element is, right? So let's say for 3 right here, that means that, element number 3 is going to be lithium on the periodic table. So you can either put the element symbol, Li, or write out lithium. Either way is fine. But then the second thing, right? Remember, they want 2 things for it is label it as either an atom or an ion, right? Is it an atom or ion? And that part should be fairly easy for you, right? If it's an atom, the number of protons and the number of electrons are going to be exactly the same. But this one right here, 3 protons and three electrons, 1, 2, 3, right? Those are the only things you have to worry about. That means that this guy right here, it's going to be an atom. Everything's totally fine. But then what you always want to do is just count, right? Number 11 right here. If I look, I've got my periodic table right here on my phone, right? But you can look on page number 20. Element number 11 is sodium, right? So I can either put Na or sodium. Either one's totally fine. Then is it an atom or an ion? Well, it says 11 protons, right? And then look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. That means this guy right here is an ion, right? So I would write ion for it. So you've always got to do you've always got to do 2 things for each one of them. Let's do one more together, right? 8, all right, let's look it up on the periodic table. You've got yours on page 20. It's easier for me. I just go to number 8 is oxygen on the periodic table. So I can either put an O right here or write oxygen. And then 8 protons, and then let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. It's not even close. That's a definite ion right there. Don't let the neutrons fool you, right? They have the neutrons down here in the bottom. Those don't have anything to do with these 2 workbook pages, right? So you want to go in and fill in these guys here, and then, page number 29 there, right? Then the final page for writing things down is going to be this guy right here. Was this 20 or no 30? 30 is your last page right here. For this one, it's just writing down the names of chemical formulas that happen, right? So instead of it just being one element connected together, it's going to be what happens if, fluorine and lithium are together, right? The way that you would say that is lithium fluoride, right? And so you need to know a couple quick rules about how you write the names of them, right? And the first thing is just the positive ion comes first. So whichever one of these 2 is positive, in this case it's lithium, that's what you write first, and that's why they wrote lithium, first for it. Then for the second half, right, the second half or the negative part, there's literally the whole book of different rules that you have for it and everything. So they try to make it super easy for you. All you have to do is remember, in this case, it's F with a little minus because it's negatively charged. Find it down here, right? Where's the F with a little negative charge is right here. And it tells you what to write. Fluoride, which is what they wrote right up here, right? So if we did the next one together here, right? Find the positive thing first. Well, the positive one is right here, Na or sodium. So you could just write sodium in there. And then for the second half of it, well, that's the negative part. It's HCO and then -3, kind of is the way you could have it. So if we find HCO and then the little -3 right here, it tells you bicarbonate. So you would write bicarbonate. So it's going to be sodium bicarbonate is going to be the answer for that one, right? Then for the next one right here, number 3, well, the K is positive, so potassium is going to go first. And then all that it is just the I with the little negative symbol beside it. So we find it down here, it tells you the answer, iodide, right? So it's going to be, right here, it's going to be potassium and then iodide, right? And so that's all you need to do, go through each one of them. Find the positive number, that goes written first. Find the positive find the positive element, write that first. Positive number, element, write first. Each one of those that are positive, if it's more than one element, you just write out both of them and everything. That's no big deal. And then you just look up what the negative thing is down below, the other option for it. Okay, that's page 30 right there. And then page 31 is the last one, but page 31, you don't have to write anything for. It's just the explanation of what we've gone through over and over again, right? Atom, right, means that it's going to have the same number of protons and electrons, right? If an electron is given away, right, they become ions, instead of being atoms anymore, because either they're gaining electrons in this case or losing electrons is what's going on with that, right? So that's all that kind of stuff that happens for us. Then the very last thing for us to do today, right, after you work on those, let's see if I can find this, is going to be, should I bring it up on here? Oh, here we go. The build an atom, right? Build an atom. Am I still here? Right, is the build an atom. So there's a link, again, in Schoology right there for build an atom. And what you want to do is you're going to go through each one of these 3 things, right? If you don't get all this finished, right, do all that stuff first with your workbook. Get as much of this done in class as you can. And then in your in Schoology, it just tells you take out a piece of paper, and there's a little link for today's lesson, just a page that you can go to, and it tells you, it asks you questions for each one of these, right? So you go through first like atoms, right? And it tells you click on first like net charge and mass number and stability, right? You want all the kind of information in there, and then take about 5 minutes and just kind of go through. What you can do is it's almost like creating your own atom, right? There, you're creating your own atoms that you have. If we keep it super simple, right? Hydrogen, just one proton actually makes hydrogen. If you want to make it official, you have one neutron and one electron in there, and look, it's all happy and stable, right? If you add an extra electron in there, it kind of shows you, what's going on. Look, I have two here. It fills up its innermost energy level, and then all the other ones go in the next energy level because it has more room for it and everything. If we add more neutrons in, well, look, it becomes unstable, right? Just like, if you have too many protons or too many electrons, is not happy, they're not happy unless everything kind of balances out, right? And so what you can do is you kind of play with that. It shows you over here the element name. It shows you the charge, depending on, protons compared to electrons, and the mass number, right? And then, the isotopes, that kind of messes with the mass number. If you remember, we were talking about that earlier in the year, right? So you kind of go through for that one is the first one that we have. The next one is this guy right here, where you're playing with symbols, right? So you're playing with symbols, but you're doing the same basic idea. You're kind of playing around here. But this one, it gives you like the big, like atomic square from the periodic table, right? So same thing on that page in Schoology, it tells you, what you can do. It asks you a couple questions for it. Then the last one is kind of the fun one. There are 4 games for you to play that you can click on down here. So you can go through the different games, right? And they just, it's kind of fun, like find, the element. So like for this one, look, there's one proton, so it's going to be hydrogen right there, right? And then they're asking you, is it a neutral atom or is it an ion? Well, look, it's got one proton, one electron, so it's going to be neutral, right? It's not an ion with a charge, and it's happy. Yay. So go through those 4 games and just kind of play for a while, um, with experimenting with the different elements and having a good time with that. All right. Hopefully, I'll see you soon, and have a good time.